أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. Now welcome to our video that is going to be an overview of all the videos we considered previously, about 13 videos. Now without any delay, I will delve right in. What you need to know before writing the CA, an overview. First of all, we will talk about vectors. Remember that vectors have magnitude and direction. A vector, any vector you see in physics, a vector has this. It has magnitude plus direction. These two are what defines a vector. That's the first thing you should know. Okay, but a scalar, if it is a scalar has only this one, magnitude only. This is another thing you should always remember. Another thing about vectors is that sometimes we may not be given the diagram. We will be given a statement about the vectors. For example, I can say I have a vector A, and this vector A is 80 meters. Then I will give direction due east. I didn't draw anything. Then I can also say, okay, I have another vector B, and this vector B is 50 meters due west. For example, you see here are two vectors, but how do I get A plus B? Very simple. Remember the cardinal axis. The cardinal axis, this is north, this is south, this is east, this is west. This one is due east. Remember, due east should be positive because it is analogous to our plus x-axis, and west is negative because it is analogous to our negative x-axis. So this means this is a positive vector. The one due east and the one due west is a negative vector, and adding them will mean that the first one is positive, plus 80 in meters, plus the second one should be negative, which is minus 50 in meters. Just subtract them, 80 minus 50, and you have plus 30. So your answer will be plus 30 in meters. You need to know this one. Sometimes the diagram, they don't have to draw this. They say, okay, this one is your vector A, and then they draw another one like this, and they say, okay, this one is your vector B, so that you know this one should be positive, this one should be negative. It's not always like that. Sometimes it will come in form of a statement. Okay, next thing about vectors we should keep in mind is finding the magnitude of a vector. Let's say I have a vector F, and this vector has 3 components along the x-axis. It has 2 components along the y-axis, and then it has just 1 component along the z-axis. How do I find the magnitude? I will say square root 3 squared plus 2 squared plus 1 squared. Magnitude here squared, magnitude here squared, magnitude here squared. Now simply bring your calculator. This is how you do in a calculator. Press the square root, then press open bracket, then 3 square plus 2 square plus 1 square, close bracket, and then you press the equality sign. When you do that, for example, open bracket, 3 squared plus 2 squared plus 1 squared, then you close bracket, you press equality sign, is going to give you 3.74 approximately unit. Now another thing we should know is the interpretation of the dot product. When we say A dot B is equal to 0, what do we mean? When we say A dot B is equal to 0, what inference can we make about the two vectors? If A dot B is 0, it means the two vectors make angle 90 degrees with each other. It means they are perpendicular to each other. Don't forget this one. Whenever A dot B is 0, it means the angle between them is 90 degrees. In other words, they are perpendicular to each other. This angle between them is 90 degrees. Maybe vector A is this one and vector B is this one, so that the angle between them is 90 degrees. Thank you. Okay, look at this example. Look at this one. If I have a vector and I write it in this form, let's say I have vector F. This is vector F, and then I say this vector F is equal to 4j plus 7k. Or let's say I have a vector again G, and then I say this G is 9i cap plus 8j cap. Okay, here in the first one you can see that I don't have I cap. What does it mean? It means the vector has no component along the x-axis, because I cap is unit vector along the x-axis, and we don't have it here. This means it has zero or no component at all along the x-axis. So this means I have 0 I cap here. Okay, no component. And here I have the I cap, I have the J cap, but I don't have the K cap. It means it has no component at all along the Z axis. So this one should also be remembered, please. It has 9 units along the x-axis, 8 units along the y-axis. Here 4 units along the y-axis, 7 units along the z-axis, but no unit at all along the z-axis. Okay, moving on. Another thing we should remember is when we have a vector that makes an angle with the horizontal. As I said, it's not always in a diagram form. Sometimes it will just be in a statement form, and you need to interpret it. Let's say you are told that you have a displacement vector and that the magnitude of this displacement vector is 30 meters. Then they also say that it makes angle 85 degrees with the horizontal. Okay, now the question is, what is the vertical component? Simply, this is the magnitude. Let's call this vector r, and then this angle is theta. Vertical, the magnitude of the vertical component is just r sine theta for vertical. For horizontal, r cos theta, without drawing anything because you have limited time. So your r is 30 and your theta is 85 degrees. So you have sine 85 degrees, and you quickly take your calculator and press 30 sine 85, then you press equality sign. This is gonna give you 29.88. I'm going to approximate this 29.9, for example, unit. Okay, so this is also very important. If they say get the vertical component, use this one. If they say get the horizontal component, use this one. Simple. Moving on, let's say we have a vector, okay, and let's say I have vector f, and this vector f has 2 components along the x-axis, then it has 3 components along the y-axis, and finally it has 5 components along, or let me put negative here, because sometimes it comes as a negative vector. Okay, it comes as a negative vector, k cap. Then this is a force vector. Let's say we have a displacement vector. It means this force displaces an object, and the displacement is measured as let's say we have 2 also I cap here, and then minus 4, this is j cap here, and then plus 3, and this is k cap. Now the question is, what is work done? Given that the work done is the dot product of force and distance. If they say what is work done and they give you this formula, simply substitute the value for the F, and then the F will be 2I cap plus 3J cap minus 5 K cap, and then dot, the X is 2I cap minus 4J cap plus 3K cap. When you do that, you move on and say, okay, take this and this, multiply them together, 2, 2, and then plus, remember our dot product technique, take this 3, and then this 4 is negative, take the negative sign as well, this is negative 4, then plus, this 5 is negative, okay, so negative 5, this one is positive 3. Now the rest is the business of your calculator. Open bracket 2, close bracket, open bracket 2, close bracket, plus, open bracket 3, close bracket, open bracket, negative 4, close bracket, then plus, open bracket, negative 5, close bracket, and then open bracket 3, close bracket, then you press equality sign. As quickly as possible, I have negative 23. Then you put joule here. It means the work done is negative. Okay, so then you look at the option and see which one gives you. What am I putting this J? Because they already said work, and work is measured in joule, just like energy. So I put capital J for that. The next thing is, what is the formula for calculating the magnitude of a vector? Suppose you have a vector R, and this vector has component along the X, then it has component along the Y, and then it has component along the Z. Okay, how do I get the magnitude of vector R? Magnitude of vector R, written as just R, should be square root of, I will take the magnitude along the X and square it, plus the one along the Y, I square it, plus the one along the Z, and I square it. Always remember this one as well. Okay, moving on, the next idea I think that is relevant. Let's say I have a velocity vector, and then I am told that this velocity vector is along the plus x axis, and it has a magnitude v is equal to 25 in meters per second. Now the question is, how do I write this in vector notation? In vector notation, since I am told that this is along the plus x axis, then I know that the unit vector along the plus x axis, along the x axis, whether positive or negative, my unit vector is I cap. So it means my vector is equal to, remember, since it has only along the x axis, so is v sub x, then I cap. Then my v sub x is this one, because we are told that it is along the x axis, so this should be 25 in meters per second. Okay, open bracket, close bracket, then I put I cap. This is the only thing I have, so it means I will have where am I going to write this? Okay, I will have v vector is equal to 25 in meters per second, everything, then I put I cap. From here, everyone knows that this is its magnitude along the x-axis, and I don't have j cap and k cap. It means it has no component at all along the y and the z axis. This also should be remembered. Okay, should also be remembered. Good. One more thing, don't forget that the cross product of a vector, okay, the cross product is not commutative, meaning that if I have two vectors, this is vector A, and I take their cross product, okay, the answer will not be as B cross A. It's wrong. Okay, remember vectors are not multiplied in an ordinary way. If I have 5 times 6, this is same as 6 times 5, because anyone will give you 30. Anyone you take will give you 30, 30. But for vectors, it's not the same. Okay, if I have A cross B, okay, A cross B, then and I get B cross A, one of them is the negative of the other. It means A cross B is equal to negative B cross A. If I interchange them, then I have to put a negative sign. So if I have, for in general, if I have vector C cross vector D, for example, then I get D cross C. The two are not the same. Okay, if I put equality sign here, I have to put a negative sign here. One is the negative of the other. This should also be remembered very well. Okay. Suppose we have a vector here. Let's say I have a vector f, and this vector f has component along x, I cap, plus it has component along y, j cap. Then I still have another vector r, and this r has also component along x, I cap, and it has component along y, j cap. How do I get f plus r? How will this one look like? Simple. You add them component wise. You add them component wise. This is I cap and this is j cap. Then you take all these along the x, you add them here. You have f sub x plus r sub x. Then for here, you take this one again, f sub y plus r sub y. That is it. This is how it should look like. Okay, you add them by their component. You take the component along the same axis, along x for both of them, add them together. Then along y, add them together. This is how they should be added. Okay, this is how they should be added. What next? What is the next thing? Okay, please do not mind the language that much. The language, don't mind the language that much. Okay, always remember how the vectors are added. That is more important. Let's say I tell you that I have a force vector, and this force vector F1 acts on a particle, and that its magnitude is 3I minus 4j, I cap, j cap. Then I have another vector that acts on a particle F2, vector 2, and this one is minus 3 I cap plus 4 j cap. Then I ask you, what is the resultant force on that particle? Very simple. The resultant force, which you can call F, is just the vector sum of the two forces. Don't forget that. It's always the vector sum of the two forces. So you simply add the two forces and see what you will get. And your forces, when you are adding, don't forget you are adding them by their component. So add the component. I have only I and j. Okay, since I have only I and j here, this is 3, this is minus 3. So here I will have 3 minus 3, because if I say plus minus, it will again lead me to the minus. And here I have minus 4 here, and I have plus 4 here, So this one will give me 0 I cap, and the other one, minus 4 plus 4 is also 0. So plus 0 j cap. So at the end I have 0. It means the resultant force on the particle is 0. The resultant force on the particle is 0, definitely. Wow, this one is very interesting. Is one of the things I love most about vectors. Let's say I have a vector A, and this vector A has component 2 along the x-axis, and then let's say 4 along the y-axis, and then 3, let me put negative here, minus 3 along the z-axis. Then I ask you to get the unit vector along A. This means unit vector along A. What formula should I use to get this unit vector? Very simple. It's equal to vector A divided by the magnitude of vector A. Simple. Don't forget that. The vector A divided by the magnitude of vector A. Now the question is, what is vector A? What is vector A? Vector A is everything that you have here. So this means this is equal to 2I cap plus 4J cap minus 3K cap divided by the magnitude of this A. How do I get the magnitude? Square root. I take 2 squared plus 4 squared plus minus 3 squared. And this is equal to 2I cap plus 4J cap minus 3K cap. Okay, then divided by, okay, let me see that, square root, open bracket. Don't forget that. Press square root, then you open bracket. 2 squared plus 4 squared plus 3 squared, you close bracket, and then you have 5.3. So because this number is not the number I am getting out of the root is not a whole number, so I will better not do that. What I will do, I will only simplify what is in the square root. I will just say 2 squared plus 4 squared plus 3 squared, and this will give me 29. So I have square root of 29. Then I will divide each one here by the 29. So 2 divided by square root of 29. Then I have I cap plus 4 divided by square root of 29. And I have j cap minus 3 divided by square root of 29. And I have k cap. This is what we call unit vector in the direction of A. Very, very important. Don't forget this, please. At this point, just take your calculator and simplify what is in the bracket. 2 squared plus 3 squared. Ignore this negative. Just plus 3 squared. What you have will be 29, and then you have square root of 29, and you proceed with the division and leave it like that. It will give you the unit vector along along A. Why do we call this unit vector? Because if I find the magnitude of this vector, it will give me 1. That is why they call it unit vector. Let's see that if it is true. I like checking. You know, the magnitude of the unit vector, this magnitude of the unit vector should now be square root. Wow. You take this and square it. 2 divided by square root of 29. Everything here square. Then plus 4 divided by square root of 29. Everything here square. Plus 3 divided by square root of 29. Negative here. Everything square. Okay, let's see. This is equal to square root of 2 squared is 4. Square root of 29 square. Square will cancel the square root, and I have 29. Plus 4 squared is 16 divided by 29. Then plus minus 3 squared is 9 divided by 29. And look at it. Let's continue. This is equal to, since I have the same denominator, I will just put 1 and I will add the numerator. So add it and see. 4 plus 16 plus 9 is equal to, it will give you 29. And we know that 29 divided by 29 is 1. So you have square root of 1. And this is equal to 1. You see that? This is why it is called a unit vector, because the magnitude is 1. Okay, so that makes sense. Okay, makes sense even from the name, of course. Okay. Wow. Another thing we should know is, what is displacement? You know, there are many ways of defining displacement. If you like, you can say distance moved in a specified direction. That's also displacement. But there is one idea about displacement that distinguishes it from distance. We say displacement is a change in position. Don't forget that displacement involves change in position. When the position of an object has changed, we say it is displaced. If it doesn't change, the displacement is zero. This is very, very important. Now, let us assume that a particle move 50 meters. 50 meters due east. You have a particle, it moved 50 meters due east. Okay? And then it reverses again. It moved 50 meters due east. Then it changes direction and move northward, and then covered 40 kilometers. What is the magnitude of the displacement? Very simple. You in this direction, or let me draw the cardinal axis to guide you. You have north here, south here, east here, and then the west here. Okay, now if it moves 50 meters east, then I will take this one as my vector, 50 meters. Then north, look at the direction of the north here, upward. So you draw it upward like this, see? And then this one is let's say 40 meters. What is the displacement? You have two vectors here. You see, the displacement is the resultant of the two vectors drawn from the tail of the first vector to the head of the last vector. And if you look at the geometry, this is a right angle triangle, so you quickly say, okay, my displacement is x, and then my x should be square root of 40 square plus 50 square from Pythagoras theorem. So you take your calculator, press square root, open bracket, 40 squared plus 50 squared, you close bracket, and then you press the equality sign. This is gonna give you 64.0 approximately in meters, and that is the magnitude of the displacement. Okay, always very important that we know this. Now, another idea about displacement. If a car, for example, starts from rest and it covers 100 kilometers due north, again north upward, so upward here 200 kilometers as an example. Now this car reverses direction and moves, let's say 120 kilometers due south. Okay, look at your cardinal axis. Where is it here? Here, north upward, south, you see, is downward here. So if you take north as positive, then south here down should be negative down here. But when it moved from here to here, it covered 200 kilometers. Then it reverses direction and moves back, and I said 120 kilometers. This means it hasn't reached here. It stopped somewhere here, and this should be negative 120 kilometers. So to get the displacement, it means its displacement is from here to here only. This one is your displacement. And how do you get it? Add the two vectors. 200 kilometers minus 120 kilometers. That is the addition. And this will give you plus or 80, I think 80 kilometers. And that is what you have. As simple as that. So always remember this one. A vector in one direction, if it is positive, then in the opposite direction should be considered negative before you now add the two vectors. Now, the next one, moving on, I can see that we are moving pretty fast, guiding each other towards the highly advertised test. Okay, the next thing is, what if you are asked, what is the slope of a displacement time graph? I have a graph, and then this is displacement, okay, in meters, and then what I have here is time. Now if this is the line I drew and I calculated the slope of, I measured the slope of the line, the slope of the displacement time graph represent what? Simple. Remember this formula, it says velocity is displacement over time. So the slope should represent velocity. Okay, the slope should represent velocity. Don't forget that. The slope should represent velocity. Now, what about the velocity of an object? You know we have different kinds of velocity. But the velocity of an object at any given time, we call that instantaneous velocity. Also, take note of that, instantaneous velocity. Now, here, let's say a particle moves, and that the displacement of the particle can be described using this formula, 20t plus 6t raised to the power of 4. Now, how do I find the instantaneous velocity when the time is just 1 second? After 1 second, what is the velocity? Simple. Your velocity, first of all, find the expression for the velocity, dx dt. Don't forget that. And then this means you are going to differentiate this one. If you are differentiating this, it has just 1t. Remove the t, you have 20 plus, and then here take this 4, let it multiply 6. 4 times 6, this is 24, and then t, reduce the t by reduce the 4 by 1. Now you have 3. Then when the time is 1 second, your velocity will be 20 plus 24 into, you put 1 raised to the power of 3. 1 raised to the power of 3 is 1 times 24 is 24 plus 20, this will be 44 in meters per second. But please always use the calculator. Just press 20 plus 24, open bracket 1, close bracket, raised to the power of 3 is equal to, and you have the 44 directly from the calculator. Okay, don't forget that. Okay, what if they say now get the acceleration? How do you get the acceleration? Your acceleration is dv dt. This is the formula you can use to get the acceleration. Acceleration is dv dt. And now you got the expression for the v. Look at the expression for the v. This one, 20 plus 24t. Now differentiate this expression again. If I differentiate 20 because it has no t, and I'm differentiating with respect to t, it will be 0. Then again I will bring this 3, it will be multiplied by 24, and I reduce it by 1 unit. So I take my calculator and say 24 times 3 as quickly as possible. I get 72. Then t raised to the power of 2. After 1 second I will put that this will just be 72t squared, and after 1 second I will substitute 1 for time, and this will be 72 into 1 raised to the power of 2, and from the calculator I will get 72, and my unit is meters per second squared because it is now acceleration. Good. Wow, we are making progress, and I love it. I love it. Seriously. Okay, what about velocity time graph? If I have a velocity time graph, remember there were two important things I mentioned about this graph, meter in meter per second, and then this is time in second. The graph, the slope of the graph is acceleration. Don't forget that. The slope, it represents acceleration. Slope for this graph is always equal to acceleration. Then the area under the graph, represent distance travel. Don't forget these 2 points. They are gonna help you. The area under the graph represent the velocity, the total distance covered. It seems like we have to make 2 videos because it's like this video is pretty long. I don't want it to exceed an hour. Okay, it's better we split the video. So clearly we may need another video. Remember, we have different kinds of acceleration. but acceleration at any time is instantaneous acceleration. You can have average acceleration, uniform acceleration, okay? But if the acceleration is changing, every second has its own value, and you want to know the acceleration after 1 second, for example, then that acceleration is instantaneous acceleration. That's what we call it, instantaneous acceleration. Don't forget that. We also mentioned that if a particle starts from rest, or that particle is released from height, then v sub I, meaning the initial velocity of the particle, is always 0 meter per second. Also, this one is very, very important. Again, if the velocity of a particle is not changing, your acceleration is 0, because acceleration is change in velocity over the time taken. So if the velocity and this change in velocity means v2 minus v1 divided by time taken. So if this velocity is not changing, it means the final velocity and the initial velocity are one and the same thing, and when you subtract them, you will have 0. For example, a car is moving with a velocity of 20 meters per second. After 10 seconds, for example, the velocity is again 20 meters per second. So this is your V1, this is your V2. So V2 minus V1 will be 0. And when you divide it by time, you get 0. So if velocity does not change, your acceleration is 0. Don't forget that also. Very, very, very important. Okay, so I think we will have to stop here, and tomorrow I will see what I can do. I have to prepare additional video. They have to be 2. I wanted the video to be 1, but looking at the length here, we will stop here, inshallah. Please take note of all the points I highlighted in the video. So, assalamu alaikum wa rahmatullah.